Hi guys, I wanted to talk to you about two proof problems that are very interesting, and I think they will help you better understand angle relationships and how to create a flow two-column proof. So remember, a two-column proof has to be really logical, and it has to be flowing like in good order and kind of makes sense. So looking at number 38 on page 139, line L is parallel to line N was given to you. Also angle 12 and angle 8 are congruent, very far away from each other on two different transversals. Angle 12 is on transversal J, while angle 8 is on transversal K. And again, L and N are the ones given to me parallel. But somehow they want us to use this information to reach that J is parallel to K. Well, a good start will be to basically redraw L and N because they are given to me parallel. So these I can use. And to pretty much pick a transversal. Either I pick J or I pick K. If I pick J, as you see, the angles that are available are only on the top. So we have only angles on the top on transversal J. We have no angles on the bottom. And we agreed that the angles that are used to prove parallel lines, like same side interior, same side exterior, alternate interior, alternate exterior, or corresponding, these 5 angles, one of them needs to be on the top and one on the bottom on the transversal. So line J is not an ideal line to choose in that case. So therefore I'll choose line K as my transversal. We have angle 8 was one of the angles that are used. And we have angle 12. So what we're trying to do is we're trying to find a bridge angle that can relate with angle 8 and can relate with angle 12. So if we analyze, angle 8 is congruent with angle 2. Also, angle 8 is congruent with angle 4. Why am I thinking congruent, not supplementary? Because they use congruent, so in that case it will be easier for me to follow what they started with. So angle 8 and 2 congruent because alternate interior. Angle 8 and 4 congruent because corresponding. So you can choose either one. We'll do both. We'll do one with 2 and then another proof we'll do it with 4. So I'll choose 2. So let's create the two-column proof. So first of all, I looked for the two parallel lines and I found an angle that's kind of related to angle 8. It's also related to angle 12, so it's kind of a bridge. It links the two angles that they want us to work with. So we'll start by writing the given, L parallel to N, and that's a given. Angle 12 congruent to angle 8, and that's a given. And we concluded based on L and N that angle 8 and angle 2 are congruent, alternate interior. And if we analyze, because we normally analyze the steps after we make a conclusion, if we analyze, you'll see that angle 8 was used twice. Excuse me. So therefore I can say angle 12 congruent to angle 2, and that's the transitive property. Now looking back at these two angles that we reached. So now our step is to look back. So if we look back, angle 12 and angle 2 are kind of related to J and K, which we're trying to really work with. But we can't say that 12 and 2 are alternate exterior here, although they are, because J and K are not parallel yet. So therefore, if we reached those two angles somehow, basically by using the transitive property, now we can conclude that J is parallel to K because these angles make alternate exterior. So when do we write them? When we write that J is parallel to K. We have to write that first. And we use the word converse because it is the converse of the theorem. The theorem tells me that if I have alternate exterior angles congruent, then the lines are parallel. Well, we're kind of reversing it. If the lines Actually, I take that back. The theorem says if the lines are parallel, then alternate exterior angles are congruent. So we're reversing it. We're saying since we have alternate exterior angles, then the lines are parallel. So converse of alternate exterior angles. So that's when you write alternate exterior, not in the previous step where we're still using the transitive property and J and K are not parallel yet. So in this step you have to use another property like the transitive or congruent supplement theorem. But then later on when you say that J is parallel to K, you can use those angles. So that's one way. Another way is to basically write the same givens, but instead of working with angle 2, I could have worked with angle 4. So I could have said that 8 and 4 are corresponding angles and therefore congruent. So I could have worked with angle 4. So angle 4 congruent to angle 8, and those are corresponding instead of angle 2, corresponding angles. And again, you'll see that angle 8 was used, and the transitive property will be the case. Angle 12 congruent to angle 4, transitive property. Whoops. As transitive property, and I'm abbreviating. Now, looking at 12 and 4, which we reached, you'll see that they have something to do with J and K, and they are corresponding. So now we can say that J is parallel to K, converse of corresponding angles. So two ways to do that one, and they're both very valid. Your key is to just find a bridge angle, whether 2 or 4. You can pick either. Alrighty, hope this helps. Let's go to number 39. So that's number 39, pretty much the same exact diagram, but different givens. So now I'll label the lines. L and N are these, which we used as parallel in the first proof for number 38. But over here they kind of used, let me try that again. That's J and K. They kind of used the opposite lines given parallel, so they actually gave us J parallel to K, and they asked us to reach that L is parallel to N. So they kind of reversed it. So I'll do the same exact thing with the same exact process. I'll draw the two parallel lines, J and K, and I'll pick a transversal. Either I pick N or I pick L. But if I pick N, you'll notice that, again, we have some angles over here, but nothing on the bottom. And it's not like a really good line because it doesn't have any angle relationships out of the 5 angles. So we'll pick the top line. We kind of have to because the bottom line, again, doesn't have enough angles going on. So the top line over here, it has all the different angles, but really they want us to work with 8, 9, and we have to find a bridge angle. So if we look at the original picture, we have 8 and 9, and we have to find an angle in between. So I can go different routes with this, but we're going to try to find an angle that has a relationship with 8 and has a relationship with 9, like for example angle 4 or angle 3 also. So any of these angles would pretty much work. So just for using other properties, we'll go in and say that we'll use angle 3 for this one. So I have angle 3 down here and angle 9 over here. And I'll write the givens. J parallel to K, given. Angle 8 plus angle 9 equals 180. That's given also. And we agreed that we're working with line J and K, and we'll agreed we use we'll use angle 3, just as an example You can use any of these angles again. So we're working with J and K. 9 and 1, you can use congruent corresponding. 9 and 4, supplementary, you can do that. 9 and 3, congruent, alternate interior. So we'll do maybe 3 and then another one with 4 so that we get good practice. Alrighty, so 9 and 3 are congruent, alternate interior, so that's what we'll say. Angle 9 congruent to angle 3, alternate interior angles. And doesn't that mean that we can do a substitution since angle 9 and 3 are the exact same thing? Then I can take out angle 9 and put angle 3 in. So that's what I'll do. I'll take angle 9 out and I'll rewrite the exact same statement, but I'll plug in angle 3 since it's equal to 9. And that is substitution. Now angle 8 and angle 3, if we look at them, they have something to do with L and N, which we're trying to reach, and they are same side interior angles with N and L and N. So I'll say that L is parallel to N, converse of same side interior. And same side interior angles are supplementary, which is what we proved, so therefore that proves that the lines are parallel. So that's one way. Then we get another way, we can use angle 4. So I'll go ahead and erase that diagram so that I can do it in another way. Oops. So we'll go to angle 4 for just practice. So instead of saying angle 3 is congruent to 9, I'll work with 9 and 4. In that case, they're supplementary, same side interior. So I'll go ahead and write the givens. And I'll write what I concluded, picking angle 4, that angle 9 plus angle 4 equals 180. And the reason is same side interior angles of parallel lines. And yes, I can write same side interior because I'm working with J and K, which are given to me parallel. Now looking at that, angle 9 was repeated twice, and I'm not doing substitution because there is nothing equal to angle 9. However, I can now take the different angles since they're both supplementary with angle 9. We agreed that we can set those congruent, and since they're both supplementary with 9, that's the congruent supplement theorem. And if you're confused between the congruent supplement theorem, the transitive property, and substitution, you can always go back and rewind the video to see the differences between all these three very, very crucial, important theorems and justifications that we use all the time. So now that 8 and 4 are congruent, I can look at the diagram again, and you'll see that these have something to do with L and N, and they are corresponding angles between L and N, which we're trying to reach. So that's what we reached exactly. I can now say L is parallel to N, converse of corresponding angles. Alright, I hope this helps, and you can ask me any questions in class if you still have questions, and I hope that you can now feel more confident about proofs. Right, thank you.